Did you know that DNA breaks occur in cells every day? Luckily for us, cells have devised a way to fix these breaks using DNA repair pathways. Some DNA repair pathways are better at fixing breaks than others, but it all depends on the situation the cell is in. DNA repair is a bit like ripping your pants in public. Imagine that you didn't have time to go home to fix your pants. You'd have to cover it up or patch it quickly. Let's consider another alternative. You have time, the tools, and the talent to sew your pants so that they look like they were never ripped in the first place. What I'm describing to you is essentially how cells decide how to repair their DNA. Is it going to be a quick fix, or is it something that's going to require more precision and specific tools? Now, imagine that you're out with your friend and you rip your pants and they say, "Hey, you ripped your pants." You're probably going to be embarrassed and startled, but you're going to stop what you're doing and you're going to go try to cover up or fix your pants. Cells have the same exact signal that tells them to stop what they're doing and to go and fix their DNA. This signal is called the DNA damage response. My research focuses on how long-term arsenic exposure affects the DNA damage response and DNA repair pathways. Arsenic is odorless, colorless, and tasteless when it's dissolved in water, and so people don't even know they're being exposed unless they get their drinking supply tested. Long-term exposure to arsenic induces DNA breaks and cancer development. However, how it's inducing these breaks and cancer is not fully understood. To study the long-term effects of arsenic exposure, I culture human skin cells using low doses of arsenic for long periods of time. Why human skin cells? Because a hallmark of arsenic exposure are skin lesions in sun-protected areas. Using these methods, I've been able to see that even after 2 months of arsenic exposure, a major DNA damage response protein called ATM has reduced activation. When ATM isn't active, this would mean that cells can't repair their DNA breaks or even know that they're there. This essentially would be like your friend trying to signal to you that you have a rip in your pants, you not getting that signal, and still walking around with a rip in your pants. Through my research, I hope to discover which DNA repair pathways cells choose to use after being exposed to arsenic, and whether arsenic-induced cancers prefer to use some DNA repair pathways over others. This could provide insight on how to treat arsenic-induced cancers in the future. How are cells repairing their ripped pants after arsenic exposure? Only time will tell.